All right. Welcome to our first meetup in a while. We've been doing some Airflow meetups, but this is our first sort of non-Airflow meetup at WePay. So thanks for coming. We're going to be doing these bi-monthly, so every couple months. And I'm going to try and theme them a little bit so that we'll explore some different areas. We're going to have one on gRPC. We're going to have one on scaling engineering and tooling, security, a lot coming up. So I encourage you guys to join up. I'm Chris, by the way. I work at WePay. I'm a principal engineer here. Few words before we get started. I'll do some intros. But before that, I wanted to make the obligatory "we are hiring" call out. So we've got positions open for engineering everywhere from junior to staff. So if you guys are interested in working on fintech, distributed systems, all that kind of fun stuff, definitely find me afterwards. So the inspiration for this meetup actually was sort of a musing that I had on Twitter, where I basically just shot out a tweet saying that it was a bit of an illusion that the web services databases were thought to be encapsulated, because all the downstream stuff in ETL actually depends on it. So when you do things like make backwards incompatible changes or forwards incompatible changes, actually the pipelines downstream get affected. So you have to start thinking about your DB schemas as almost an API. And that's something that we had experienced a bit here using Kafka Connect, which is a connector system to be able to suck data out of your database and load it into Kafka. And I got some really interesting responses on Twitter. And two of the responses came from folks that are here today. So one of the talks we're going to have is from PayPal, from Deepak and Romit, who are going to be talking about Gimel, which is an open source, or soon to be, is that soon to be open source? I don't know what to call it. ETL pipeline, ETL tool, data API. Okay. And then we're going to have another talk from Carl after that, from LinkedIn, Carl Steinbach, on Dolly, which is another integration layer that LinkedIn uses. So it's really in this sweet spot. And I hope you guys all enjoy it. And so we'll take as long as the talk takes. We'll probably do some Q&A after each one, and then hang out and close up shop 8:30 or 9, I think. So thanks. And bathrooms are back the way you came, by the elevator, if you need them. So yeah, without further ado, here's the PayPal folks.
Thanks, Chris. First of all, thank you, Chris, everyone at WePay, for this meetup. Thanks for having us. My name is Romit. Let's share. My name is Romit. I'm a product manager for data processing products at PayPal. I have with me Deepak, who's going to talk about Gimel itself. And there are several members of the team that built Gimel, so feel free to ask questions before, during, anytime. After, of course, we'll be here. If you can, next. Just by way of the agenda, it's very short. Why we built what we built, and then, of course, what it does. So you can skip the, yeah, no, it's okay. We can skip this. I think we already talked about it. Before we jump into why we built, some key PayPal numbers. I don't think we need to go into the actual numbers themselves, but the growth. The point we are trying to make here is PayPal is seeing a lot of growth across the board. Customer accounts, transactions per customer, volume of payments, everything. So how it impacts us in the data platform, we are seeing an exponential increase in the volume of data that we have to process. And that has, of course, we have moved to big data world a long time ago, but now there's an increasing pressure for analysts who are used to Teradata and Oracle to start using Hadoop and ecosystem of Hadoop more extensively. So that's one of the reasons why we built Gimel, and we'll go into the details in a bit. Just a little bit about the PayPal's big data. We have about 25 Hadoop clusters, 13 prod, 12 non-prod. We have GPU, as most cool tech companies do. We are one of the largest Aerospike, largest Teradata, largest Hortonworks, largest Oracle deployments. 150 petabytes of data in the Hadoop world. We run about 40,000 yarn jobs a day, and we support MapReduce, Pig, HighSpark, Beam, and then we are constantly evaluating new compute frameworks. So let's get into the details. Why Gimel? Why did we build Gimel? By the way, at any given time, if you have any questions, please feel free to interrupt. This is not meant to be a full-on lecture, so anytime you see something you don't understand, you have any questions, please feel free. The first example, this is a real simplified view of one of the team's workflows. This is in the risk area with financial risk, fraud detection. They're getting events from our website and mobile apps. And because PayPal is 15-year-old, at different times, different applications started using different messaging systems. So now we have 3 production, maybe more. The 3 that I know of are these 3 messaging queues. They pre-process the data and then they put it on Kafka so that it can be run through a compute engine. Then again put on another Kafka so that it gets into the persisting engine, and then finally run the decision service. So the decision service is, let's say I'm trying to log in. I have last 3 months logged in from Santa Clara, and then suddenly there's a login from China. The decision service has to make a call, should I let this login get through or not? So if you detect something that sounds fishy, it's going to use this Aerospike data to figure out whether that is a valid login that we should allow or not. So that's the kind of final result of this entire flow. Along the way, they persist a lot of data to HDFS to do all the computations, and then in Aerospike for the very fast access that is needed, because the decision service has a very strict SLA because it's in the login flow. We don't want to have our customers wait for 10, 20, 30 seconds for a simple login. And it's not limited to just login. There are many decisions that are being taken based on this flow. Oh, and by the way, along the way, all of this has to be logged and monitored and audited, because anytime any of these things fail, somebody needs to be woken up. If you think about the developer in the risk team, what do they care about? What is their core competency? All the middle parts, the data pre-processing, because they know how to cleanse the data, the computation, they know what to merge, how to find all the patterns. They know where to persist, what to persist, and then of course, how to derive the decision. What do they not care about? Everything else. All the data read, the data write, all the persistence, of course, all the logging and monitoring and auditing. That's not their core competency. They don't care about it. They have to do it. They may not do it all in a uniform way. They may not do it at all, which means they're exposing themselves to possible outages and so on. All of this is something that Gimel was built to address, and we'll see how and what helps in all of these things. If you look at our other set of users, that was the developer. This is analysts and data scientists. First thing is, as they move to the big data world, unlike a simple command like show tables or what all are there in this database, there is no such thing to go across HBase and Hive and Aerospike and Elastic all at once. So they're having a hard time finding data. Where is the data that I need to use? I know what it sounds like, I know what it could be, but how do I find it? How do I access it? So they're having problem just finding data. What else? If they want to run interactive queries, today there is no good solution, performance solution, user-friendly solution for interactive queries. First of all our Hadoop and everything, and I'm sure with other companies as well, there is no simple way. You can't go to a browser and start using Hadoop. You have to go to some bastion, then from there you go to some gateway host, and then you're still within the command line interface. Additionally, if you want to access data across multiple data stores, you're going to have to write different types of queries for each data store. Again, from the same command line interface. There is no friendly interface to do any of those things. And analysts who are used to using fat clients like Toad or SQL Assistant from Teradata or whatever, find it really hard to use these kind of solutions. So adoption is low. And then finally, in the new world, we are using streams a lot. As soon as a product is launched, analyst that supports the product has to start looking at what are the numbers. Are we seeing some hits? Are we seeing a dip in transactions? Whatever it is, they need to find in the first hour or 2 hours of launch. They cannot do it because they don't know how to access streams because they are used to using SQL. So what do they have to? They have to wait for some engineering team to do the ETL or ELT process and then persist the data in some sort of Teradata or Hive system, which that they can query using their familiar SQL. But that means they're going to have to wait for half an hour, sometimes 24 hours to see that data. And they cannot react to any bad incident that may have happened in the part of launch. And it's not just launch. In general, if you want to see the pulse of something happening at that time, it's really hard to get near real-time access to analysts and data scientists. You don't need to go through the actual code itself, but this is what we are trying to show here is in order, if you're using Spark and you are reading data from HBase, there's 30, 40 lines of code that you have to write. And goes back to the earlier example of the risk team. They have to maintain this with all these properties and everything for every single data store that they use. And then they have to touch this every time any of the pieces change, because all of the variables, like the storage system, the Spark itself, the API version, the client library, everything is embedded in this code. So anytime infrastructure team wants to change something, every developer has to go touch this, which means it adds inertia to the upgrade. We slow down innovation. That's just HBase. And then if you look at, no one is using just HBase. In companies like PayPal, there's hundreds of data stores. So imagine a team that has data coming in from Kafka that is persisted in HDFS, and then they are using HBase for some fast access, Aerospike. They have to write 4 or 5 different types of code just to read from data stores. And again, that is not what they want to do. They want to focus on making their code better so that they can run decisions in shorter amount of time. All of this creates a lot of overhead for the development teams. And again, this is part of the reason we have built Gimel. The double clicking into the data sets challenges, besides just being able to find data, unable to find data, there are other things. Because of the way Hadoop has evolved, there is no central catalog at all. So we have things like, we talked about this as well, data access tied to the compute and the storage. But then other things are like, because you are familiar with Teradata, you're going to move data from Hadoop to Teradata. That means you are duplicating the data just for ease of access. Instead, if you were able to access directly where the data is produced, you would have no issue. There are no standards for onboarding data sets, so I can write my own data. Tomorrow, somebody else can write the same thing with maybe one minor change and not realize that it's kind of creating another set of duplications. There's no audit trail who's accessing what data set. So we have petabytes of data, but who knows how much of it is actual really used data. And then there is no statistics on who has accessed what. If you want to find what is hot data layer, what is the cold data layer, since we don't have statistics, we cannot really put things on cold storage versus warm storage versus hot storage. As a result of all of that, here's what data application lifecycle looks like. So you have first time that you start building a big data app, you go through the process. I think that's okay. You have to learn new technologies. You go through all of that. But then as soon as you move, let's say from MapReduce to Spark, you have to do all of it again. As soon as your Spark goes from 1.6 to 2.2, you have to do all of that again. Your storage API changes, same thing. Storage connector changes, same thing. You have, we constantly move our host from one data center to the other or one location to the other. We sunset some hosts and bring some others. Whenever that happens, because all of that was in your code, you have to do all of that again. If you move from HBase to Aerospike, you have to do all of that again, and on and on and on. So the life cycle goes much longer than it should be. Time to market goes much longer than it should be. And as a result, there's frustration both infrastructure side, you cannot upgrade any of these things to get bugs fixed or to get new features, and from developer perspective because they don't want to do anything. And I'll give you a quick overview of the ecosystem for our Gimel. This is just a very simplified version of what Gimel looks like. Not all of these pieces are Gimel, but most of them are. Everything below this is infrastructure. But if you look at from a user access perspective, we have the Gimel SDK, so you can build using 2 APIs. And then we've enabled notebooks, Jupyter notebooks. How many have used notebooks? Jupyter, okay, several. So we've enabled notebooks to be tightly integrated with Gimel so that analysts who use notebooks can access all of the big data technologies without having to learn all the new stuff with the big data technologies. We'll focus on the data platform specifically for this talk. We are here, we can talk about all the other pieces offline, but there's enough to discuss within data platform in the data API and the PCatalog, which is our centralized catalog, to take up all of the time. And to demonstrate what we have built, we'll go into the details of what we have built, what is behind Gimel, but before that, Deepak is going to walk us through an example. It's a flight cancellations application. It's looking at fictional data, but this is exactly how we have implemented it at PayPal as well. Why don't I let Deepak explain what the app is? Any questions so far while Deepak comes over? Anything about what we did, why we did?
Sure. Thank you, Romit. So let me set the stage here before we go and look at what Gimel is. I'd like to start with the use case and give you some perspective of what analytics world is typically is, what the product development life cycle is, and then finally go to Gimel to show how we are trying to simplify all these pain points. So what we have here is a simple use case of analyzing flights cancelled in the quarter of 2017. So we have a simple dashboard here which gives the total number of flights cancelled in the last quarter, the drill down by the month, October, November, and December. And also we have the top 10 days where the flights were cancelled and a look at the cities, double clicking on each of the dates. And on the top right corner, we have the segmentation of these numbers by the airlines that had the cancellation, and another segmentation by the reason for cancellation. And finally, we have a layover of the number across the map of US, giving us the cancellations across all these airports in various cities. Now, this is a small dashboard with few details, but having said this, the first question that we need to answer before we get to the dashboard is what are the data points that we need. So we looked at points such as getting flight events from source and to destination, then airports, airlines, carrier, geography, because we need to build a map. And then we immediately jump on to the next question, which is, where is my data source? I have all these data points. How can I collect them? How do I source them? Typically in our organization, we end up having conversation with other teams across organizations, and we may have meetings. Maybe we look up the internal search portal, there are some catalogs, and we figure out there are some potential data sources, and then we need to validate them. Let's assume that we found that the events data is in Kafka, and then we have some kind of geographical information in an external source, and maybe we have some lookup information in Teradata. But once we have all these sources, the immediate problem that comes into picture is how do we ingest data from Kafka? We have to go through the semantics of accessing Kafka. As Romit mentioned previously, we need to write a code. That's one of the big challenges we have today. There is no easy access to Kafka by a SQL. And even if it's an RDBMS system, you will probably have to look at various ways of performing an extract from Teradata and load into Hadoop. So that again involves some kind of challenge. And if it's another external source, then we need to work through the semantics of the type of resource it is. And once we have all of this information in place, we have to probably look at how do we process the data in an efficient manner and analyze it. So that leads us to the next question. How do I persist my data? Do I persist in Parquet? Do I persist in ORC? Is my query columnar based so that I need to persist in Parquet and so on? Those are the things that we need to resolve to really work through this data analysis in an efficient manner. And finally, if we move across all these and we still have one more challenge, like Romit mentioned, there is a CLI that the analyst has to go through, and it's not a really good experience. And to be able to publish a report out of this, we need to perform some extracts, move the data out of several hosts, and then create a Tableau dashboard or some kind of visualization. But let's assume we went through all of these and we are now at a stage where we have vetted our POC and we want to productionalize. The next challenge is you cannot take the same process and put it in some code and run it, because you have brought different touch points into picture and you need to write different kinds of code. And if you are an analyst, you may probably end up talking to another data engineering team who is going to write some code and then do the DevOps for you. Or if you are the developer who did the analysis yourself, again, you would have to transform your analysis into some kind of application, maybe a Spark streaming application or a Spark batch application. So these are all the different challenges we have in mind. Now, before we jump on to the Gimel demo, I want to give some high-level idea of the concepts we are going to talk about. So there is a very high-level category of data store, and then there is a data store type, and there is a data store itself. So for an example, data store category is RDBMS, and in RDBMS we have so many systems like Oracle, Hive, Teradata, and within data store we may have several databases. For example, in Hive we have a RiskDB, TrackingDB, DWDB. This is going to be something that we are going to talk very frequently in the coming demo. Any questions? So Gimel is, as Romit mentioned, it's a unified analytics platform. It consists of the compute platform, the data platform, and we have something called the PCatalog and discovery services. So PCatalog is nothing but PayPal's catalog. It's supposed to be a single source of information for metadata across all the data stores we have in PayPal. And this is the landing page of PCatalog. So if you try to recollect the challenge we had so many different data points to gather, and the search term that we were looking for is flights. So I'm going to go and look up flights here. So the first challenge we had is how do we solve accessing the different sources? So you have to talk to different people, organize meetings, do several searches, but we are trying to solve that by coming to one single place, one single source of metadata, and look up everything here. So I'm looking for flights information. So I came here on the landing page and I'm searching for flights. I find several data sets here which are related to flights. I'm going to double click on one of the data sets, maybe flights Kafka, it's of my interest. So I'm just going to give you a very high level of the data set concept. So this is the overview of what a data set is. I can see that there is an alias name called flights Kafka. By the way, dataset is just a logical name for a physical object. So here we are talking about a Kafka system. So the data is actually persisted in the Kafka topic format, but we are actually having a logical name on top of it. So you can have n number of logical names. There is no deduplication. There's no duplication of data as such. This is an overview which tells me this is flights Kafka. It's created by Deepak. It's created on a particular date, last updated timestamp. I'm going to hover onto the schema details. So I see that the schema is dynamic. Maybe I need to figure more details. And then I see something called the system attributes. So here I can see various information, like what is the storage type, which says it's Kafka. That gives me an indication that, okay, this data set is residing in Kafka system. And I can see some properties which are binding to the actual storage system. So this one is the host for the zookeeper of the Kafka cluster. And there is something called schema registry. How many of you are familiar with Confluent schema registry? Okay, that's great. A lot of familiarity. So as we saw before, there is something called a dynamic schema. So when I look at this particular piece of information, I see that there is a schema registry and there is a wrapper key. So this gives me some information that the data and the schema are going to be dynamic, and I need to be looking up the schema registry, but that's not something I'm going to do. It's the API which is going to do on the fly. And then I have something called the object attributes, which is more specific to the data set itself. And here I can see that there is something called value serializer, key serializer, average schema key, the actual Kafka topic itself. If I expand on the data format, I can see that this is string serialized. So all the data in Kafka is in string format, key and the value. And there is something called the deployment status, which gives me information on whether this is a usable data set. So I can see that this data set is approved for use and all these different clusters, which means I can go to any of these clusters and access this data set without any worries. It's all certified and vetted by the owners of this particular topic. But
and
this is
one thing to note there, through the system attributes and object attributes, you can already see that part of the fragility has been taken away from the analyst or the developer, because they don't have to worry about maintaining this information in their code. As you can see, as long as they access the logical name, all of these information is transparent to them. The Kafka administrator can change any of these properties. As long as they refer to the logical name, their code will not have to be.
Yeah, I got the question. Let me repeat it. So your question is, what if you as a user wanted to use the latest instead of the earliest, right? Yeah, so this is a default property which we pre-register on the fly. But when we get to the data API demo, I will show you that you can override all these properties as a user. You have the choice to do it. But we want the users to have the best experience, so we try to have certain set of properties which we load as default for each storage system. However, all of these can be most of these can be overridden by the user on the fly. All right, with that, giving you a very high level overview of the search, which is the main feature of the Gimel. We have a lot of other features here as well. So if you remember, I showed you a quick snippet of the data store category, data store type, and data store. So we are going to take a closer look at what these actually mean. So I'm on the data store category page here. So you can see that at a very high level, these are the logical classifications of data store types. We have a NoSQL data store, a document data store, streaming, RDBMS, in memory, and we could have something else in the future. And you may notice something red here. So what this means is, as an admin, I have the capability to enable or disable any data store type or a category. What this would in turn mean is all the objects that are actually covered within this data store can be completely disabled or enabled in one click, so that the users can or cannot access it with one administration effort. Also, if a new storage admin comes into picture, let's say we introduced Alucio support and we want to add a new Alucio here. So the Alucio can be added here through the create data store category. Mostly this is meant for the usage by Gimel admins and storage admins. Let's take a look at what is data store type. So we previously looked at document-based, in-memory, RDBMS, NoSQL, and streaming. If I click on any one of these, I can see the subclassification of the actual data store types. So in RDBMS, we have several types like Oracle, MySQL, Teradata, and Hive. For the sake of the demo, I have just two things here. And if you look at the details again, we can enable or disable a particular data store type specifically. Also, we can take a look at the attributes. So these are some of the attributes that one would be binding the data sets with, and it's applied across all the data sets in this particular storage type. Let me take a look at another one, maybe streaming. So you can see here in the beginning when I did search for flights, I got a flights log. I clicked through it, and then I was looking at various properties. The storage level properties which Romit was talking about, all of them are mentioned here. So these properties that we see here will take a binding on all the Kafka storages that we have. We may have n number of clusters. All of them can be controlled with in one place. So far we have looked at the logical classification, the subclassification of different types of data stores and data store types, but this is the actual physical clusters themselves. So if you see here, I can go and hover at Kafka, and I can see there is a actual Kafka cluster that's going to come up. Oops. This is why we wanted to do a, yeah. Let's wait for it. Okay. All right, there we go. So I came back to the data store. I double clicked on the Kafka, and I see this particular Kafka cluster we have here. You can go and look up the details, and we would be looking at the exact same details that we saw that was associated with a particular Kafka topic and the data set before. You can see the zookeeper, the schema registry, the master schema, and the broker, and all those details that we associate with a particular Kafka cluster. All right, now we've seen all these high-level features and the categories of data stores that we support. Let's go to the data sets. So this is the typical place where all the users are going to land in. The first three features that we looked at is mostly meant for administration, either by the Gimel admins or by storage admins. But datasets is the place where all the users are going to come and look and explore all the catalog. And I have probably 8 to 9 datasets here mocked up for the demo. But in our production, we have tens of thousands of these datasets. So in most cases, the usage pattern would be you come here, you look up, maybe you want to look up Teradata, you get all the Teradata datasets here. And maybe you want to look up by a particular server, you have a prod cluster, you have a Teradata dev cluster, your POC, maybe I'll look up prod. And I can see that I have a flights lookup, airline flights lookup, cancellation, flights lookup, carrier code. And I can even go and look at the details of what this particular data set is. You can see the schema. I have 2 columns here. By the way, when I talking about schema, we have something called the Gimel discovery service, which is the a core engine which scans all the different storages that we have in PayPal and loads all of them here and maintains them. So it basically is a service which uses a super user. For example, if you have 1 or 2 HBase clusters, it could go and scan all the namespaces and all the tables that we have in the HBase cluster, maybe sample few records in the HBase tables, build a schema and bring it back here. On similar lines, we can set up certain databases to be scanned in each storage type, and based on that, all the tables in those databases can be scanned and then brought back here to the user. So if I look at the system attributes, it shows me that we are trying to use the JDBC protocol to access the storage, and there is a particular server detail here, and there is a driver here, and also what we are looking here is a logical name which is just which has no physical association to it, but the actual table that resides in the Teradata database is this particular table we have here in flights DB, and the name is flights lookup carrier. Any questions so far? Okay, it's a good question. So it's managed by the discovery service. So there are two ways you can do it. So the discovery service, when it discovers all these hundreds of thousands of tables in Teradata, it assigns a logical name by itself, because we don't want the user to go through the experience of searching for an object and registering it. But since you asked, as a user, I have the capability to give my own logical name to an object, which is not very typical because it's a duplication of names for the same object. But I can do that. I can go and give Deepak as my username, maybe flights 123. So here I can choose which particular data store I want to look at. I'm going to pick up streaming. Since we have just Kafka support, if we add AMQ, like Romit mentioned in the beginning, we have AMQ, Kafka, and other kind of streaming messaging platforms. If we add AMQ support, you will be seeing AMQ here. But today we have support for Kafka, so we are seeing Kafka. And within Kafka, you will be seeing a number of clusters. We have one markup cluster, so we'll be picking that. And we have the concept of namespace. So the namespace can be either a database if it's a Hive or relational system, or it could be the actual namespace if it's the HBase. In our case, Kafka is really, it's just a logical concept. So we associate the actual subject matter as a namespace. So we have the flights. And I can see there is a couple of topics here, flights log, flights data. I'm going to choose one of them based on whatever I browsed before. I'm going to click register. So now I have created my own data set. I can go back here and I would be seeing the new data set available soon. So there you go. So without knowing the underlying semantics of what cluster details it is, what is the zookeeper, what is the broker, what topic it belongs to, what is the serialization format, I was able to create my own data set on top of a particular Kafka topic. All the values that we have are bound here, and you can see that there is a pending registration, which means this is not yet ready for deployment because I'm not running any of my underlying discovery services yet. So this is not going to happen at this point. So in summary, we had the challenge of finding our sources. We came to the PCatalog UI and we came and we looked at flights. We got all these different sources. Now we know that our flights Kafka is our source. We know the lookup that exists in Hadoop Hive. We know our lookups which are coming from Teradata. We are ready to access them. Any questions so far before I move forward? All right. Okay. So what I'm doing here is I'm here at PayPal Notebooks. PayPal Notebooks is nothing but Jupyter Notebook with a ton of additional features that our notebooks team have added. So we have taken into consideration all the different pain points that our SQL users face today. So they like working with MySQL Workbench or Teradata Workbench, Teradata Studio. They like the experience there. But when it comes to big data, the experience is not so great for them. They have to go through a CLI, or even if they come through Jupyter Notebooks, they have to start their own notebooks behind the scene, and then it does not work in a high available mode. And there are many other challenges. So all of these features have been covered through our PayPal notebooks, and it's a separate topic for discussion. I will probably focus on what our focus is for the demo. So what I've done here is I've come to the notebooks, and since we have solved the first problem we had, where we are trying to look up for the catalog, we are now going to look at the second challenge. We are going to analyze and prototype our POC. So I'm starting a Spark session here on Yarn cluster, and I'm going to cache flights event from Kafka. We know our Kafka dataset, the logical name. I'm going to pick up the Teradata data, the 3 tables that we looked at. And we also have the geography information, which is coming from HDFS. And finally, we are going to combine them, do some analysis. And once we are ready and comfortable with the data, we're going to push to Elasticsearch, which is going to power the Kibana dashboard, which we looked at the beginning. And the other challenge that I'm going to cover is, even if you did all of this, this is just a analysis SQL. How are you going to productionalize this? And how are you going to do the DevOps if you want to do streaming versus batch and all these semantics? So we're going to look at that as well. So what I'm trying to do here is, I'm going to read data from flights Kafka. If you remember, this is the table that we found back in the PCatalog UI. And the other thing to observe here is we have something called the PCatalog tag here. This is what is going to change the Gimel SQL's execution mode. So we have something called the Gimel SQL, which I will be covering later if we have time. Basically, every query that we run or fire on the Jupyter notebook, PayPal notebook, it's going to be intercepted by the Gimel SQL. So Gimel SQL looks at the tag that is tied to the table. If it is PCatalog, it's going to generate the Spark code behind the scene without allowing the query to go through Spark SQL engine. So as you can see, I've picked the data from Kafka, and we have around 1.3 million data coming from Kafka. Let's look at the data. So we have the flights information with the flights date, the origin, destination, and we also have a flag to indicate whether the flight is cancelled or not, and some other metrics here. So with one single SQL, I was able to read Kafka without knowing where the Kafka topic resides, what is the cluster, what is the format, and what is the semantics. Let's move on to the next step. Now we are going to cache the geographical information, which was residing in HDFS. So again, if you see here, I'm running a simple SQL, which is a regular analytics SQL. We have some kind of row number rank function, which is analytics function, and we are doing a transformation, trying to calculate the latitude and longitude because we need that to plot the geography later in the map. Again, the thing to observe here is, this is the table we picked up from the PCatalog UI, which is a logical name, and this database is necessary for the Gimel SQL parser to intercept the SQL and change the execution mode so that the code is generated behind the scene. While this query runs, let me move on to the, oh, sure, lost connection. Should I restart? Oh, I lost VPN. Connecting again. I'm gonna have to restart the notebooks. All right. While we re-execute all these steps, let's look at the last step that we had. So we're gonna have to cache the data that we looked at from Teradata. So you can see here, I'm picking up the Teradata carrier code lookup, the airline ID lookup, the cancellation code lookup, and again, we are using the PCatalog database to tell the interceptor that this is a PCatalog code or a Gimel code, so you need to generate the Spark code behind the scene. Right. So far, what we've seen is we have pulled data from Kafka, we source the data from Teradata, and we also source the data from HDFS. And you can see that all of the execution is complete, and I can even get the data from Teradata. I want to show you something here. So we have the code and the description from this particular table that we picked from Teradata. If I just jump back to the UI here, I can see the code and the description. So we have a schema binding on the fly. Oh wow. I actually have a connectivity problem, I think, getting the VPN connected over again. Do you see a change in the screen? I'm gonna have to stop sharing. Let me try that. You have the meeting ID? Wait. 124. Let me check here. Okay. We seem to be running out of time. Let me rush through the remaining demo. So what we did is we pulled data from Kafka, Teradata, HDFS, and you can see here I'm combining all this information together. I'm taking the Kafka data, Teradata data, HDFS data, and I just have all the information now enriched and ready to be pushed to Elasticsearch, which is our target. Let's just examine the data quickly. You can see here, this is the information which you previously looked at, but now you also have the additional information that we processed. But you can see that we have combined all these different data sources with just a single SQL in one place. We did not have to go through any of the pain points or the touch points which Romit had mentioned earlier. And finally, we are here ready to push data into Elasticsearch. So again, we are just going to try an insert SQL on an Elasticsearch dataset using the PCatalog. Right now, I'm just pushing 10 records because we already have the data there. But it's just to illustrate that we are able to push data into Teradata with the same insert SQL. Let me run the select query just to make sure we have the information. And you see here, the additional 10 records have been pushed. And the ES is now updated. So this is all fine. We did our analysis, we created a dashboard, and then we vetted all of this together. But now the next question is, how are we going to productionalize it? So yes, yeah. Any new index that is created, it's automatically discovered by the discovery service. So we configure the discovery service to go and scan anything that's in the Elasticsearch cluster. So if somebody put a new Elasticsearch index, which we are not aware of, it's automatically brought in and it runs almost every 15-20 minutes. So we have a look. There is some latency involved, but still it's updated very quickly. So this snippet that we have here is all we need to do to productionalize the same code. So this is the code that we initially looked at to combine all of the data sets from different storage systems. All we have to do is add a magic. This is something we call as Livy magic. We can talk about it if we have time, or maybe after the talk, come to us and we'll show you what the Livy magic is. So by adding just the Gimel stream magic or a Gimel magic, you can basically make this code run in a streaming mode or in a batch mode. And that magic happens by using the Gimel tools. So we have a simple SQL here where we are saying %Gimel, and we put that SQL in a file, and we are going to use the Gimel tool and start a Spark application in cluster mode in the Yarn cluster, and it's just going to take the SQL file and execute it. So if you're running a streaming application, you just put -stream, but if it's a batch application, you just leave it as Gimel. That's all it takes to move from an analysis vetting to production. Any questions so far? So we have a UC4 scheduler, we have an airflow scheduler. So we use one of those depending on the choices of things. And the last challenge we had is we ran all of this as a user or as a batch application. Where is me auditing and logging? So we have implemented all the logging, auditing, and monitoring behind the scene. Any SQL that you run is automatically captured, it's indexed, and it's available for our view. So the SQLs that we ran recently, they're all available in our indexes. Which shows who is running the SQL and whatnot. For the sake of security, I have actually cut down some of the columns so you cannot see, but there is more to this. And we saw only SQLs, but behind the scene, the SQL generates Spark code, and each line of those codes is actually captured in the index as well. So you can see here there is some insert SQL ran, but there was actually an API involved in calling. All of those information is captured, but again for security reasons, it's not show certain things, so I'm just going to show it. And you might be wondering whether this is all SQL. It is not. So if you are a programmer, you need more choice, you need flexibility, and you need control. You can actually use the API without going through the SQL. This is an example of a streaming code, streaming from Kafka, doing some use case. But you can see here, data stream is the API that you need to use. This is the Gimel API. There are dataset API and data stream API. So use the data stream, you create a streaming result, which is a wrapped object. And this is a typical Spark streaming code. You can do whatever you want. And finally, if you have something to write, you can call the dataset.write. And SQL implicitly checkpoints the checkpoints. Implicitly checkpoints the offsets. Whereas in batch mode, you have the flexibility to call it wherever you want. We have functions that are available to you. Any questions so far? So just a summary again. So we had all these challenges, and you looked at a demo of how we can solve all of these. But what we have done is we want to have a simple touch point for user. Go to the PCatalog UI, browse your catalog, gather your datasets, go to the Notebooks UI, do all of your analysis, come back to Gimel tool, schedule. You don't have to go anywhere, learn code. The time to market is very fast. That's the main motive of it. Sure. So the tool itself has capabilities to send alerts if there is failure from an operational perspective. Beyond that, we have the compute platform, which we have not covered here at all. Basically, everything that we are running here is running behind on the compute platform, and that has several logging and monitoring capabilities. And maybe after the talk, we can show you details. I don't think we have the time, but there we have a lot of monitoring, alerting that we have, which can be used by the applications. Let me quickly show you one small thing because you asked this. So we looked at having several clusters. So Livy is our compute platform. We actually have contributed a lot of features to Livy. Maisam is here. He did a lot of cool stuff on Livy, so you can talk to him for more details. So we integrated the notebooks with Livy, the data science tools with Livy, batch applications with Livy. So right now, Livy is the one place through which all our applications go through to Yarn cluster. And going back to your question, so the user applications have the feature to turn on monitoring and alerting. And we also do alerting and monitoring implicitly, regardless of what the user applications do. They all go to Kafka and they go to Elasticsearch Index. And then we have a Kibana dashboard, and users just go to the dashboard and then they're able to look at their particular applications. But again, I'm not able to show the dashboard here because it has a lot of PayPal stuff. And this is our in-house monitoring and alerting tool. So especially if you want to send some alerts, we have the capability to provide an API. You can just send an alert for a particular rule that you have, and it goes through this entire pipeline and you get an alert. So this is the compute platform so far. On top is the challenge we had because of which we introduced the Gimel API. We have so many different data sources, like Romit mentioned, you have so many semantics and so many different challenges with versions, time to market, time to learn, and so on. To completely remove all of those from the equation, the Gimel API is the unified data API that we have. Again, you looked at the logs that the API produces. It has the auditing capability, the same pipeline. So we have different touch points to actually cover, but I think we have run out of time. We made changes to Spark Grip Server with one single line of code. Now the Gimel code actually runs its own SQL instead of the Spark Grip Server SQL. Similarly, we made a lot of changes to we made simple changes to Jupyter Notebook, and we introduced a new IPython magic. And here we have the metadata services, which is the meat. So all of our Spark applications interact with the metadata services, which actually scans and discovers all the data sets from various places. And finally, we have the UI, which we looked at in the beginning. So putting it all together, if you see on the left top pane, the user has only two touch points, the PCatalog UI and the Jupyter Notebook. That's what we want the user to have. Any questions? I will probably let Romit to wrap it up if you want. Okay. Which, yeah, it's a good point. Yeah. Sure.
Yeah, you could have done it, but in terms of what's coming, you have a question? Yeah, so at PayPal, we have already inner sourced Gimel, which means besides our team, anyone else within PayPal can contribute. And we already had two connectors, data sources that have been external contributions. They said it was fairly easy and straightforward. Druid and Couchbase are both, Couchbase is in the process of getting merged, but Druid and Couchbase, both those development teams said it was fairly easy. They understood the code and they knew exactly what they had to contribute to extend the breadth of offering for you. So from their words, we are kind of biased, so we are going to say it's easy, but this is what they said. It was fairly easy for them to incorporate their own connectors.
So what we have thought through this, what we so there's two questions here. One is the while you read and write, how close is your schema in terms of what is there in the actual store. And the second one is within the catalog, right? Whether your schema is stale or not. So in terms of read and write, the configuration is always at 3 levels. You can see at the catalog level, we had a configuration which is by default, which is set by the admins. And then the dataset owners, they can set their own properties, which will override. Or you as a user, when you submit application or you do a dataset.read, you have an option to pass. You can say, this is my property, override everything else. So there is a choice for user. It can be at the user level or at the dataset level or at the storage system level. That's on the read and the write.
We can talk about it offline. I think Carl needs to
I'm gonna suggest we parking lot the rest. It's awesome to have great questions, but I do want to get Carl up here before everyone has to take off. So thanks again, guys. If you want to give him a round of applause, and Carl can come on up.